Before we construct a regression model, we should first verify that a linear association exists. Otherwise, our model isn't valid. But if we have a strong linear association, something close to 1 or -1, then we can create our model and predict future or unknown values. And then we'll talk a little bit about how we verify. There are a lot of different methods for verifying if our model is making good predictions, but we'll talk about that briefly. The table below provides information on the average market share for Internet Explorer and the homicide rate in the United States per year. We want to start off by finding the linear correlation coefficient, and then if we have a strong association, find the linear regression equation, and then make a future prediction. I have this data entered into Desmos already. We can start off by calculating the correlation coefficient using the command CORR, x1, y1, and we get in this case a correlation of 0.9477. With that value being close to 1, we know we have a strong positive linear association between these two variables. So we can go ahead and find the linear regression equation. By identifying those values for M and B using Desmos. So our linear model in this case would be y equals 0.031x plus 3.452. Then in part C, we can use this to identify a future or unknown value. So in this case, assuming the Internet Explorer market share drops to 28%, what would be the predicted US homicide rate? So keeping in mind that the way we set this up, Internet Explorer's market share is our X value. We'll simply plug that value into our model. Actually, those values are entered in as whole numbers, so we'll keep that as a whole number. So we'll multiply by 28, substituting that in for X, to get 4.32. So our model predicts that if the Internet Explorer market share rate dropped to 28%, then the US homicide rate would hit 4.32. Now this is just a prediction from this model. We need to think about whether or not this is a good model. First of all, we can think about the fact that there probably is no cause and effect relationship here. So however many people are using a specific internet browser probably has nothing to do with the US homicide rate. So there's an intuitive step here which would tell us this model's not probably a very reliable model. But another way that we could do this is, another way we could assess our model is by comparing it to some updated information. This data only runs through 2011, but we know that as of 2022, Microsoft Edge, which is the replacement browser for Internet Explorer, has a 3.7% market share. So that market share has dropped considerably. And the US homicide rate is 6.3. What we can do is plug in this value of 3.7, see what that predicted homicide rate would be, and see if a pattern still exists, if we're getting something close to the actual known value. So we'll do that by taking 0.031 times this updated value of 3.7 plus 3.452, and we get a predicted US homicide rate of 3.5667. That's a pretty drastically different answer than the real world value, which tells us that probably in the long term, this model's not holding up. It's not making good predictions. So the first thing that we need to think about is probably basing our model off of two variables that make sense in some way. There's a reasonable possibility of there being a cause and effect relationship between those two variables. And then the other thing we need to do is think about how to verify that model. One thing is, over time, just as more data becomes available, updating the original model or checking that model against new values to see if it's still making good predictions. This one's not, so not a very reliable model.